polygon. So we first have to do for the moment, so which we call it couple polygon. Okay, so that we will utilize this guy and this guy. So first, what I do, we find the scale, right? So I would want the values are not that big, the difference is not that big, so maybe I want the list to be 2 centimeters. So I want 0.684 to be equivalent to 2 cm. That means every 1 kilogram meter, so 2 divided by 0.684, that is 2.9. so every 1 kilogram meter is equivalent to 2.9 cm. So the first value, the first is array, which is 0. So we are starting to draw a couple polygon. Let me just clean this guy and leave this piece. So 1 kilogram meter squared is equivalent to 2.9 cm. So choose a point. All right. So the idea is we are going to draw the forces for all of them using their angular orientation from the positive x-axis until it closes. So if the polygon closes, then it is balanced. If it doesn't close, it's not balanced. That's the idea. So for A, the start is O, and A have the same value. So the reference and A has the same value. So I can just write A there. So from A, we move to 1. The magnitude is 1.5 to the angle is this. So to find the equivalent in centimeters, I just multiply these two at 2.9. I measure 90. 90 is here. Okay, the magnitude is 4.4, so 4.4 will be somewhere here. All right, so clean. All right, so at the end, you draw a very small horizontal line there. And that's where the next one starts. So we have the horizontal line to measure the angle for the next one, and there may be errors. So I hope you get it accurate with yours. So from A we move to 1. So just write 1 here. You can write the magnitude if you want. I don't want. So the next one, we move from 1 to 2. The angular orientation is 2 to 5, so we have to measure 45 degrees more. Let's measure 45. Yeah. The magnitude is 2 centimeters, right? So okay, that is 2 cm. Then we draw a horizontal line there. So that is from A to 1, 1 to 2, 2 to 3. Now 3, we have this. So the angle is 300. We bring it here. Then we measure. So from here to here is 180. So how much we add to 180 to give us 300? That is 120. So I'll measure 120 here. So I just need a positive x-axis, then I will measure the angle and draw the line. That's all. If the values are negative, whatever, so this one, you see the one 300 will be here. So if the magnitude is negative, I will go up. If it is positive, I will come down. So let me say, if let's say I measure 30 degrees, right, and then the value is negative, I would go down. If it is positive, I'll go up. But if I measure here and then the magnitude is positive, I'll go down. If it is negative, I'll go up. You see it? So if you are up, if the magnitude is negative, you go the opposite direction. Right, it's down. If you are down, the angle is negative, you go up. Okay. All right. If you don't understand this, you can just say it in the comment section. I will respond. All right. So now we know the 300 mark. So we just have to bring this guy here. Okay. So the magnitude, we have 2.54. 2.54 times 2.9. That's a 7.366. 7.366. So we're still not there. The 7.36, 7.4, approximately 7.4. So 7.4. Oh, that is that, exactly 7.4. Okay, so the last one should make a balance, which is the RB. So what about closes this polygon is what will make the force balanced. So let's see the moment balanced. So okay, so that's that. So let's take the measurements. You have 4.1, 4.2. So 1.9 RB. Okay. So 1.9 RB is equivalent to how do you call 4.2 centimeters, right? But we know that 1 kilogram meter square is equal to 2.9 centimeters. So how much will be equal to 4.2 centimeters? You convert it to kilogram meter square. So this one multiply, this one multiply. So 4.2 divided by 2.9. 4.2 divided by 2.9. That is 1.448, which is 1.45. Okay, so we have 1.9 RB to be equal to 1.45. So RB will be equal to 1.45 on 1.9. Let's find out what that is. 1.445 divided by 1.9. Okay, so 1.45. So we have RB to be equal to 0.763 kilogram meter square. Okay, so that gives me 124, 124, right? So you can see. So theta B from here to here, theta B was what? 124 degrees. Now previously we had theta B to be 124.1 and RB to be 0.739, and we had 0.63 and 124 as the angle, which is close, right? And again, there may be errors in mind that you should be able to get more accurate values. So we are done with the couple polygon, and now you know RB and what theta B. So the next is to find what's the RA and theta A. So same method. Let me just push it up a bit. I'm bringing it here. So same method, our scale. So I would want the list to be 2 once again. The list is 0.736. I would want it to be 2 centimeters. So I want 0.763 to be equal to 2 cm. That means 1 is equal to okay. So 2 centimeters divided by 0.763, that is 2.6 cm. All right, so I need space. So 90 degrees. Should be here. All right, so what's the magnitude? The magnitude is 4.6, right? 4.6. So you just say if 1 is equal to this, then 1.6 is equal to what? Then you just 1.6 times 2.6. So you have 4.2. 4.2. Okay, somewhere here. Okay. All right. So where we started from, over here, I had to bring my horizontal line. So this one is 0 from the origin. So the next we draw a horizontal line. So the n is 1, obviously. So we draw a horizontal line. The next one is 2, which the angle is 244. Okay, so 45 will be here. And magnitude, the magnitude we have 1.171. 1.71, which is 4.44, 4.4. So okay, so that the next is to draw the horizontal line again. I believe at this point you've seen the trick. And then you bring in this again. The next one. So from 1 to 2, 2 to 3. 3 is 300, right? So from here up to here is 180. We need 120 more, which is here. Okay, so with this, the magnitude is 1.75, so 2.6 times 1.75. That is 4.6. So we have 4. Okay, so that's 4.6. All right, so over here we still draw a horizontal line, and then we measure the next one. So the next one, the angle was 124, and the magnitude was 0.63 and 124. And then we have the magnitude was, I think, 2 centimeters. So 0.763, that is 2. So we measure 2 centimeters. Okay. And then, so yes, so this one is from 0 to 1, 1 to 2, 2 to 3, and now 3 to RB. So what will join them or close the polygon is the array that will make a balance, right? So this is the approach, the graphical approach. Okay, let me use a different color. 2.15, let's see. Okay, so 2.15, so RA is equal to 2.15 cm. Now let's increase the length and find the okay, I'm getting the 2, right, 32 degrees. So theta A, I'm getting 32 degrees. Now RA is equal to this. So if I want RA in kilogram meter cube, kilogram-meter, because I know 1 kilogram meter is equal to 2.6. 1 kilogram meter is equal to 2.6 from the scale I used. So how much of this will be equal to 2.15, which is 2.15 over what? So RA equals 2.15 over 2.6. 3.15 over 2.6. So we have 0.826 here. All right, let me see 2.2. Okay, so I have this. Now let's see, we had analytical, we had R rate should be 0.91 and this should be 34, and we are getting 0.3 to 0.8. all right, so these are the values you are going to get. I got for the analytical method, which is very close and not accurate enough. So I hope with your instruments and your hands you should be able to get an accurate value. All right, so now the asks us to find the relative and angular. Let me push this one to the side. The question asks us to find the relative and angular reactions in bearings A and B with respect to. So the reactions in the bearings, we are looking at the reaction, the force. So let me draw this. So this is the shafts in this bearing, right? The force will put this, the shaft will put this force on the bearing, and the bearing will put the same in opposite direction. So what you have calculated for is the reaction on the bearing, right? So the statement wasn't too clear, but from the examples or from the notes, you can say that they are just asking us to find the reaction on the bearing. So the reaction on the bearing will just be the one we've calculated for. But if we are looking at the reaction on the shafts by the bearing, then, so for instance, the RA, we had a 34.4 degrees. So this means the force is coming from this direction. The force from the shaft is in this direction. So the one from the bearing on the shaft will be the same force in opposite direction. So since this is less than 180, we add what? 180 to it to get it from here to here. So to be the same RA, but the angle will be plus 180. If we are looking at the reaction the bearing is putting on the shaft. But in this case, you're looking at the reaction the shaft is putting on the bearing. So we are just going to maintain the angles. All right. So the angles, if the opposite is to change, but since it didn't change, theta A is 34.4, theta B is what? 124.1. And the magnitude of the dynamic reaction is when they've given me the angular value. So A. B, RA is equal to 0.91 times 500 omega 2.60 squared. So remember I said we can factorize the omega out. So omega was factored out. So whatever we had was a kilogram meter equivalent. So if you find the RE, you need to convert it to force, which is what? You have to multiply the square of the angular velocity. And you have to change it to rad per second. So that's what I've done in here. So RA will be equal to 0.91 multiplying 1500 times 2 pi on 60 squared. So that gives us 2.5 kilonewton. RB will be, so we have 0.7 and 1500 times 2 pi on 60. $18.2 kilonewton. Now the C says we should find what? The static reaction. So static reaction, just have to draw the free body diagram. So we have weights 1, weights 2, so we have reaction here, reaction here. So these are the forces acting on the shafts. So we have the reaction B from the bearing B, reaction A from the bearing A. Right. So RA plus RB should be equal to width 1 plus width 2 plus what? Width 3. So RA plus RB should be equal to width 1, 45, 40. So 40 plus 50 plus 45. All multiply 9.81. You can find them one by one. 40 times 9.81 plus 50 times 9.81 plus 45 times 9.81. Okay, so that gives us so we have RA plus RB to be equal to 1324.35, right? Now the next is to find the moment. So for the shaft to be statically in equilibrium, sum of forces should be equal to 0, sum of moments should be equal to 0. So we take moment at any point and we expect it to be equal to 0, and that will help us to eliminate the number of what? Unknown, minimize. So we take moment at A. So from here to here, from the diagram is 0.4. So with 2, that would be clockwise. So negative with 2 times 0.4 minus with 1 times 0.95 minus with 3 times 1.45 plus RB times 1.9 should be equal to 0. So we have minus 45 times 9.81 times 0.4 minus 40 times 9.81 so RB because one 260 Okay, so we have the reactions, the static reactions, right? So that is for calculate the static reaction and then calculate the speed at the shaft should run so that the dynamic and static. So here is how you find the reactions on the bearings, right? So you could see that on bearing A, now you could see that this is a reaction on the shaft. So on the bearing A will be in the opposite direction, which will be what? So RA on bearing A will be negative 660.885, right? 885, something like this. Or you can say it is 660 at a certain angle. So you can say it is 660.885 Newton downwards, right? Now they're asking for, so this one will be for the C. They're asking for the angular velocity at which the reaction, the dynamic reaction in A is the same as the static reaction in A. So the static reaction, the dynamic reaction in terms of kilogram meter, we had 0.91. So assuming we don't know this speed, at what speed should you put it here so that the value will be equal to what? 660.8. I get it. So the thing is, this one is inclined to a certain angle, which is the 34.4. So for us to equate them, we need to find the corresponding vertical components, in this, because this static force is vertical, right? So what you're going to say is 0.91 sine theta A times omega squared should be equal to what? 660.88. So omega will be equal to square root of 660.88 all on 0.91 sine what? 34.4, which will be equal to, so we have 35.853 rad per second. So omega in terms of RPM will be equal to 35.853 times 60 on 2 pi, which is